So, good morning, everyone. Good morning, Nitin. How is everyone? कैसे हो सभी लोग? Everything okay? Tripti, how are you? Okay, very good, very good. Everyone is fine. That's good. Chalo. So, in today's class, what we will be discussing? We will be discussing largely question from SHM. Sorry, first we will be discussing gravitation, and after that we will move on to SHM. Done. So in gravitation, again, I have picked up some questions. We just need to deal with the basic here. In the sense ki, like there's not much to study in theory, but application part is more. So if you know small things in mechanics, you will be able to go with the gravitation as well. So just a general notes, I mean, general recall of which formulas are getting added in gravitation, which we have not studied in mechanics, rest part. So first thing जो आप पढ़ोगे, you must have seen that the acceleration due to gravity. Then acceleration due to gravity, how we calculate this. So if I'm taking Earth as a reference, so if suppose Karlo, this is center of Earth and at any distance r, we have to calculate acceleration due to gravity. We write g as equal to g into mass of Earth divided by that distance from the center. Okay? So these are the simple things you must have studied. What happens when what happens to acceleration due to gravity as we move away from the surface of Earth. So for surface of Earth, r will be equal to capital R. Done. For surface, it will be, and at any height h, suppose Karlo, I have to calculate acceleration due to gravity at a height h from the surface. Then you must have written g as gm by r plus h ka square. Overall, we can also say this, if this is given as a small r, we can say gm by r square. Again, at any point beneath the Earth, that is at depth b, if we have to calculate acceleration due to gravity, formula is same na. Very good morning. So formula to हमें यही लगाना है, gm by r square, where r is distance of that point from the center. So always we have to keep the logic in our head rather than remembering more and more of formulas. Because in G advanced, your approach will matter a lot, right? So यहाँ पे देखो, अगर at this point we have to calculate acceleration due to gravity, its distance from the center will be how much? It will be r minus t. So acceleration due to gravity at any depth d will be taken as what? R minus t ka square. And now depending on the approximation, if h is far less than r, or if b is far less than r, we can all deal with it, है ना? We can use binomial expansion wala thing ki 1 plus x to the power n can be written as 1 plus nx. So this wo sari cheezein to again that is just simplifying the formula for different cases. That we don't need to go here. Here we only need to focus on what the logic is behind it on and from where it is coming. Rest part you will take care of, है ना? चलो. So next thing जो मैं deal करूंगी, that is energy. Energy, जैसे suppose कर लो, this is Earth, and from the center of Earth there is an object at distance r. Done. So it has mass m, Earth has mass m. If it is asked that what is the energy of this mass m in under influence of Earth, so there can be two cases. Cases can be like if this mass is in rest, if it is stationary, then it will only have potential energy equal to minus g mm by r. Potential energy negative because this attractive force is acting upon the small mass m because of Earth mass, right? So only potential energy if that is in rest. But if this mass is orbiting around Earth, what will happen? It will have certain velocity, right? So it will have kinetic energy also, and that will be equal to half into mass into v ka square. Now, how we can calculate the velocity? Since this mass m is orbiting around Earth in circular orbit, yes, of radius r, how we can calculate its velocity? So simple hai, we will see that since it is going in a circle, there must be some centripetal force acting. And here on this small mass m, what centripetal force will act? Force because of gravity of Earth. Then, so gravitational force will act as a centripetal force here. How much value of gravitational force will look like? So it will look like gmm by r square, and this will be equal to mass of body orbiting, that is mv square by r. So velocity kitna mil raha hai hame? Root under gm by r. That value we will be putting here. So kinetic energy, how much will be? gm by r. Just half of the potential energy in magnitude. Then kinetic energy is positive, potential is negative. Again, whole energy thing that you're going to calculate will come as something minus gmm by 2r. Same as we have studied for electron orbiting around nucleus. There also we have got the same relation. Same thing is here. Okay, so we can deal with energy also. Now the last thing that I want to discuss is escape velocity will come into account. Then suppose there is a mass here and we have to escape it. How? Escaping means what? If this body is escaping Earth environment, it means it is going to such a far place where effect of Earth gravity is zero. Then that is called escaping out of Earth. Then, so if this body is escaping out of Earth, it means it has reached such a position where it can't experience any force or anything because of this Earth, right? So that will happen. Now, if it is said that suppose there is a body and it is on rest on the surface of Earth, so how much energy we should give it so that it will escape? So if it is escaped, it means its potential energy will become what? Zero, because it is not under influence of Earth anymore. So gravitational potential energy will become zero. Again, if it is talking about what minimum energy we should give it so that it will escape, means once it has escaped, its velocity has also become zero, because we are talking about how much minimum kinetic energy we can give to this body so that it will escape. For that, add r equal to infinity, kinetic energy will also become zero. So overall, we have to give it such a value of kinetic energy that will make its total energy equal to zero. Then only it will escape, right? So on the surface of Earth, it will have energy how much? Minus gmm by r. Done. And suppose I'm giving it kinetic energy or I'm giving it velocity v. So if I'm giving it velocity v, its kinetic energy will become this much. And this must become equal to zero for this body to escape, right? So if you're going to calculate it, velocity का value क्या आने वाला है? 2gm by, and this is at the surface of Earth, तो ये Earth के radius के बराबर होगा 2gm by r. So if you're going to solve it, it will come as 2gr, है ना? And in earlier case, orbital velocity will come as gr if it is orbiting near surface of Earth, right? So this is the logic. If there is a body, suppose here, and it is also orbiting around Earth, then so it will have potential energy, it will have certain kinetic energy, but if it is said that how much extra energy we will give it so that it will escape, again what we will do, we will calculate its total energy to zero. So that's the logic. That is what we have to use in gravitation. Okay? So in gravitation, we will be dealing with that. All rest thing you must be remembering, like Kepler's laws. Kepler's second law is the most important. Kepler's second law what talks about? First law says that कि जो भी हमारा planets है, that will revolve around sun in an elliptical orbit with sun at one of its focus. That is first Kepler law. Second law, what it talks about, it says that कि जो planets है, that will cover equal area in equal interval of time. That is delta A by delta T will be constant. Then it was said like that. Now, if you go on to calculating delta A by delta T, that you must try. Okay? So, what we will be getting here, if you're going to do this, जैसे देख लो, suppose कर लो कि my planet is here, and in delta T time, it is covering this much of arc. ठीक है? So, if I have taken this delta T to be very small, how much area it is covering? It is covering almost ये वाला एरिया है ना, दिस विल बी वेरी स्मॉल, दिस जो तुम्हारा ब्लैंक पार्ट जो दिख रहा है छोटा सा, दैट विल बी वेरी स्मॉल इफ डेल्टा टी इज वेरी स्मॉल, राइट? So if you're going to calculate it, area of this triangle, what you will be getting, half base into height. Base is equal to how much? Radius के बराबर है, इस point पे जो radius है. So if you're going to calculate delta A, it will be half base into height. Height can be taken as dl, length of arc. This and this can be taken as same almost. So this is dl. Now if you're going to calculate delta A by delta T, what you will see, it will be half r delta A by delta T. I'm going to do so delta L by delta T, that is dl by dt, so that is equal to velocity, so half r v. ठीक है? So अगर आप इसको ध्यान से देखो, अगर मैं इसको मास से मल्टीप्लाई कर दूं, जो कि ये कांस्टेंट है, मास ऑफ प्लैनेट से अगर मैं इसको मल्टीप्लाई कर दूं और डिवाइड कर दूं, तो मुझे क्या मिल रहा है? आर वी एम पी. mv is what? Mass of planet. V is what? Velocity of planet at this point. So mv will be momentum of the planet. What will be its angular momentum? R cross mv at this point. So this is the angular momentum. It means angular momentum, this is going to be constant now. It means angular momentum will remain constant throughout. So if angular momentum is remaining constant, it means mv r1 इक्वल टू, मैं दो पॉइंट लेती हूँ, एक ये पॉइंट लेती हूँ, सपोज कर लो एक ये पॉइंट ले लिया मैंने, इसको R1 बुला लिया, इसको R2. एक बार मेरा planet was here and another time my planet is at Q, suppose. So if it is as at P, I can write its angular momentum as mv2 R2, and if it is at 1, we can say its momentum as mv1 R1. अब आप ध्यान से देख लो, यू कैन कंपेयर वेलोसिटीज की, कहाँ पे ज्यादा होगा कहाँ पे कम होगा. सो दीज आर द सर्टेन थिंग्स दैट वी नीड टू रिमेंबर. चलो, नाउ वी विल बी डूइंग क्वेश्चंस. अगेन आई एम जस्ट बिफोर starting with the question, I must tell you one thing, questions are really easy. You just need to remember the basics and you just need to know a little bit of mechanics. You will be able to solve it. So everyone just first believe that you will be able to do it, and after that just give your hand at it. Okay, thank you. So now let's do it. I'm giving for this 3 minutes to you. ठीक है, आप इसको सही से सॉल्व करो, पढ़ो और सही से करो. If it is taking more than that 3.5 भी I'm ready to give you. ठीक है, चलो तो सही से करो. को कोई डाउट है in understanding question, solving it at some point, let me know if I can help in some way then. Yes, tell me. करना क्या है? क्वेश्चन क्या है यहाँ पे? देखो, लार्ज स्फेरिकल मास m है. दिस इज a large spherical mass m and it is fixed at one position and two identical masses m are kept on a line passing through center of m. So there are other 2 point masses m and m kept along the line passing through center of larger sphere, right? The point masses are not free actually. Point masses are connected with each other through a massless rigid rod of length L, right? And this assembly is free to move along the line connecting them. और ये जो दो मास का जो assembly है ना, यानी कि these two masses connected by rod is free to move along this line. Which line? Along the line passing through center of this larger sphere that is shown here with dotted lines. Well done. So yes, very good. All 3 masses interact only through their mutual gravitational attraction, and here the force acting only is what? Gravitational attraction, that is mutual gravitational attraction here. When the point masses near to m is at distance 3L, this mass is at distance how much? R is how much? 3L, and the tension in the rod is 0. And tension in rod is 0, and in that case it is written that a small mass m जो है वो कुछ ऐसा दिख रहा है. Then the value of k is what? This is the question basically. So what is the pickup line in this question? Everything you must have understood, but the pickup line here is tension in rod is 0. Tension in rod is 0 when this small mass m is at a distance 3L from the larger sphere. Again, one more thing we need to remember here or keep in our head is, जो आपको जरूर याद होगा, कि if there is a solid sphere or hollow sphere, be it for charged sphere or for a sphere of mass m, gravitational field or electric field at a distance r, which is where r is an outside point, then it behaves like the mass m is simply concentrated at its center. So at this point, gravitational field will be how much? Gm by r squared simply. And if you have to calculate the force, then field into mass करोगे. ठीक है, same as you have done in your electrostat. Done. So second thing, चलो first line पे आते हैं. Let's understand that thing कि tension in the rod is 0. What does it mean? If tension in the rod is 0, how, when it will be 0? Suppose कर लो तुम्हारे पास एक rod है and there are 2 persons of equal masses, then of equal masses, and they are applying force on this rod in such a way that tension is remaining 0. When it will be possible? Suppose कर लो एक rod है, अगर एक पर्सन इसको इधर से खींच रहा हो और दूसरा पर्सन इधर से खींच रहा हो, तो डेफिनेटली इसमें you will be experiencing some sort of tension in it. Then, but just consider a case where this person is just applying force on the rod in this direction. In this direction, suppose you have a spring and one of your friend is compressing a spring with some force, and you are here and you are extending a spring with some force equal to this force. Then, so with equal force, one is compressing, another is extending. What will happen? There will be no extension or compression in the spring, net extension and compression. And if there is no extension and compression in the string, tension will be 0. That is Kx. Spring force क्या होता है? K. So F equal to Kx. F tension force, that will be equal to what? 0. So when tension in this rod will be 0, when force acting on it is equal and opposite. So just see here, m mass. If m mass is at the distance 3L, what will happen? This capital M mass will apply force on it in this direction. Done. I'm focusing on this one. Okay? And this small mass will also attract this small m mass, and this attractive force will be in this direction. Done. Okay? And suppose net force that this small m mass is experiencing is in this direction. Okay? Now let's consider this small mass m. So this will get attracted by this small mass m and this capital mass n. And both these attractive force will be in this direction. So net attractive force acting on this mass is in this direction. Tension will only zero if this and these forces are what? Equal and opposite. Opposite I have drawn. So if they are equal, tension in the string will be what? Zero. So you just have to write the forces on these two masses. So what will be the net mass on this small m? What I'm going to write here, Gmm by L square, क्योंकि distance between these two small masses is L, and mass and gravitational field because of this capital M mass at distance 3L will be how much? It will be net force ही मैं लिखती हूँ चलो, that will be Gm by 9L का square, and mass force is acting on a small mass m, so field into mass. So net force acting on this small mass m is this much. Now let us write this force, net force on what? This small mass m. So it will be equal to Gmm by L square plus G, how much distance it is having from here? 3L plus L, that is 4L. So Gm by 16L square into m. These two must be equal, right? For tension to be zero. Only you needed to solve it, nothing else. So आप यहाँ पे इसको अब आप solve करो. Gmm by L square, it got cancelled, right? And which thing we are going to get now? What we will be getting here? These two will be what? Equal, now? Yes, I have equated. Now you solve it. What answers you're getting? Let me know. Some mistake somewhere, I guess. What is that? Solve karo, sabhi log. I have told you the logic. Just check it once. It feels like somewhere I've done mistake in calculation. Just check with that. और अगर करेक्ट है तो टेल मी द आंसर. एक काम करो, फोर्स को ना पूरे ही आई और माइनस आई कैप के डायरेक्शन में लिखो, जैसे और फिर या फिर इक्वेट करो. वन हु गॉट द आंसर वाज दैट हर्ष. व्हाट वाज योर इक्वेशन? व्हाट इक्वेशन यू वर गेटिंग? लेट मी नो, जल्दी से बताओ और सारे लोग सॉल्व करो. आई एम अगेन गिविंग यू 1 मिनट, 1 लास्ट मिनट, ठीक है, टू सॉल्व इट. आप लोगों को मिस्टेक दिखा या नहीं दिखा? एक्चुअली यहाँ पे डायरेक्शन में मैंने मिस्टेक किया है. जैसे इफ नेट फोर्स ऑन वन इज एक्टिंग इन दिस डायरेक्शन एंड अनदर इज एक्टिंग इन दिस डायरेक्शन, देन व्हाट विल हैपन? इट विल गेट कंप्रेस्ड ना. यहाँ पे देखो, अगर एक स्प्रिंग है, इधर से फोर्स लगा रहे, इधर से लगा रहे, इट विल गेट कंप्रेस्ड, तो टेंशन होगा. बट यहाँ पे क्वेश्चन में दिया है टेंशन इज जीरो, तो ये एरो मैंने गलत दिया था. यहाँ पे दिस एरो विल बी इन दिस डायरेक्शन. डन, एंड दैट इज व्हाई वी गॉट द रॉन्ग आंसर. तो यहाँ पे माइनस ये नहीं होगा, माइनस. ठीक, दिस वाज अ स्मॉल मिस्टेक बट अगेन वेरी सिग्निफिकेंट. तो अब आप सॉल्व करो, ये कट नहीं होगा. सॉल्व करो और जल्दी से आंसर बताओ एवरीवन. देयर वाज अ मिस्टेक इन एरो, राइट? हाय, इक्वेशन कैसे लिखा है? क्या कर रहे हो तुम लोग? Just see here what the question was. Tension will be zero, right? So if tension is zero, that you understood now. In on this small mass m को अगर आप फोकस करो ना, सबसे पहले focus on this mass. So this mass is experiencing attractive force because of this one, because of this one, and both of these attractive force will be in this direction only. Okay, so this mass is experiencing force in this direction. This mass must experience force in this direction for tension to become zero, है ना? So if it is experiencing force in this direction, net force, it means this mass will apply attractive force on this small mass m. In which direction? In this direction. Let me call it F1. And this capital mass m will attract this small mass m in this direction, F2. So if net force is in this direction, it means F2 must be greater than F1 here. Done. So try to calculate the net force on first small mass m. What will be that? F2 minus F1. F2 is how much? F2 is how much? GM by 3L का square. अगर ये समझने में problem है तो let me know. This much minus how much it will be? GM by L square. Now what will be the net force on a small, this second small mass m? What you will be writing? GM by L square plus GM by, sorry, capital M लिखोगे यहाँ पे. Capital M से इसकी distance कितनी है? 4L. So you will be writing here 4L का square. This is the net force acting on these two ना. इनका direction same होना चाहिए, magnitude भी same होना चाहिए for tension to be zero. So just equate these two, right? Now after equating, what you are going to get? Let me solve it now. So what you will be getting? आपने solve नहीं किया. You should have done it now. So what will happen here? GM by L square को मैं common लेती हूँ. 1 by 9 minus 1 by 16 will be equal to how much? इस माइनस वाले को इधर लेकर आ जाओ. लाइक ये माइनस टर्म है ना LHS में, उसको RHS की तरफ लेकर आओ. So GM by L square plus GM by L square कितना होगा? 2GM square by L square. L square कट कर दो, एक स्मॉल m यहाँ से चला जाएगा, G भी कट हो जाएगा. So what value we are going to get? यहाँ पे कैपिटल M बचेगा, है ना? Yes, इतना इजी था सच में. तो यहाँ पे क्या बचने वाला है आपका? कैपिटल M. So capital M will be equal to how much? Sorry. Capital M into 1 by 9 minus 1 by 16. So 16 minus 9 को आप क्या लिखोगे? 16 minus 9 कितना होगा? And this equal to 2m था ना, something like that. Now if you're going to minus it, it will come as 7, right? So m into 7 by 16 into 2, 32. And 32 into 9 कितना हो जाएगा तुम्हारा? वो हो जाएगा 288 equal to कितना आ रहा है? m. M is equal to k into capital M by 288. So k का value कितना हुआ? 7. Question was damn easy. You just needed to pick this line. Tension in the rod is 0. डायरेक्शन को सही से डील करना है. देखो मैंने एक मिस्टेक किया, यहाँ पे डायरेक्शन को इधर ले लिया, हमारा क्वेश्चन सॉल्व नहीं हो रहा था, आंसर बिल्कुल ही गलत आ रहा था, है ना, क्योंकि दोनों ही मार्क्स कट हो रहे थे सारे के सारे. ठीक है, सो डील विद द क्वेश्चन प्रॉपरली. चलो अब इस क्वेश्चन को करो. अगेन दिस इज वेरी इजी, आई मस्ट टेल इट. So again, I'm giving you 3 minutes. Do it fast. क्वेश्चन समझने में कुछ प्रॉब्लम हो तो पहले बता दिया करो, ठीक है? या फिर कहीं पे भी स्टक हो रहे हो, लेट मी नो सो दैट आई कैन करेक्ट इट बिफोर हैंड. Are you people getting? What the question is? Question is given ki there is a bullet and that is shot vertically upward with velocity v. From where? From the surface of a spherical planet, just like Earth. When it reaches its maximum height, at maximum height, its acceleration due to planet's gravity is how much? 1/4 of the value that is at surface. Done. It is given that escape velocity from the planet is this. In the term of v, it is written, right? Escape velocity in the term of v. V was what? The velocity from which it was sought from the surface. And all these informations are given. So escape velocity is written as v root under n. So we have to tell the value of n, right? So we just need to relate thing. Escape velocity formula, what it used to be. It used to be 2 into g at surface. If escape velocity from the planet की बात कर रहा है, in general, it means it is talking about if a body is here on the surface of planet, then it's escape velocity, right? No special case it is talking about. It simply has written escape velocity from the planet. So if simply we have to say what will be the escape velocity for the planet, we will say it will be equal to 2 into g surface into radius of the planet. 2gr पढ़े हो ना आप लोग? g क्या होता था? g was acceleration due to gravity at the surface. So this is this. अब इन दोनों को मुझे क्या करना है? कंपेयर करना है. तो यहाँ पे जो प्लैनेट है, इसके सरफेस पे एक्सेलरेशन ड्यू टू ग्रेविटी क्या होगा, इसका रेडियस कैसे होगा? We simply have to relate it, nothing else. तो आप यहाँ पे ध्यान से देखो what we will be doing here. So what is given here? It is thrown with velocity v at maximum height. At maximum height, suppose this was the surface of planet, and from here it was getting thrown up with velocity v, and at maximum height, suppose h, g ka value is given at this point. Then, so what will happen at the maximum height? At maximum height, its velocity will become 0. Then, so if we are going to do the conservation of energy, we will get the value of v from here. Then, but for that we need h. Then h ka value, how we can calculate? From the value g that is given here. If acceleration due to gravity at the surface is how much, will be how much if radius given is r. Yes, yes, her correct. So acceleration due to gravity at the surface पे आप क्या लिखोगे? G at the surface will be equal to gm mass of planet divided by r का square. Done. At any height h, what you will be writing? You will be writing gm by r plus h का square. And what the relation is given? At height h, acceleration due to gravity is 1/4 to that of at the surface. So 1/4 into gm by r square is equal to how much? gm by r plus h का whole square. That is given now. So gm को आप कट कर दो, यहाँ से 1/4 को आप क्या लिखोगे? r by r plus h का स्क्वायर. इस स्क्वायर को अगर मैं इधर लेकर आऊं तो हाफ हो जाएगा. तो r will be equal to how much? Sorry, 2r will be equal to r plus h. So h will be equal to r. Done. So height we have calculated. How much is the height? This height is equal to r. Done. Now we can calculate the value of velocity here. Why it is required to calculate velocity in term of g, m and r? Because our escape velocity is given in the term of v. So we need to find out v to compare the equation. तो चलो उसको निकालते हैं. How we will do that? At the surface energy will be how much? It will be minus g m by, if small m is the mass of bullet, by r. Here kinetic energy is how much? Half mv square. And at maximum height there will be only potential energy minus gmm by 2r. You will be writing, right? Okay. If you are going to solve it, how much value we are going to get? What value we will be getting? Just let me know. What will be that? जल्दी से बताओ क्या होगा? Yes, hers correct. That answer is correct. नहीं, मैं इसकी वैल्यू अभी पूछ रही हूँ. माइनस gmm by 2r, तो प्लस gmm by r करोगे इधर. How much value you will be getting? gmm by 2r will be equal to half mv square. तो mm कैंसिल हो जाएगा, 2 कैंसिल हो जाएगा. वेलोसिटी का वैल्यू कितना आया? रूट अंडर gm by r. This much we are getting. Done. So अगर आप अब आप यहाँ पे रखने की कोशिश करो. v escape इक्वल टू, क्वेश्चन में क्या दिया हुआ है? v escape इक्वल टू v रूट अंडर n दिया हुआ है. ठीक है. अब v का वैल्यू मैं रखती हूँ. सो अगर मैं v का वैल्यू यहाँ पे रखूं, कितना आएगा मुझे? gm by r रूट अंडर, है ना, इनटू क्या लिखोगे? अच्छा, v का वैल्यू दिया हुआ है. सो यहाँ पे v का वैल्यू क्या आया है हमारा? v का वैल्यू वी हैव गॉट इट करेक्टली ना? हाँ, चलो ठीक है. सो v का वैल्यू इज हाउ मच? v का वैल्यू इज रूट अंडर gm by r. सो v स्क्वायर अगर हम निकालने की कोशिश करें, बट यहाँ पे तो v ही रखना है ना हमें. gm by r इनटू क्या कर रहे हो यहाँ पे? रूट अंडर n. अब आप देखो एक्सेलरेशन ड्यू टू ग्रेविटी क्या होता है? gm by r स्क्वायर होगा. ठीक है. सो यहाँ पे gm by r हमारा क्या है? gm by r यहाँ पे क्या हो जाएगा? वेलोसिटी का स्क्वायर हो जाएगा ना. एंड दिस इनटू r होगा, यहाँ पे होगा gm by r स्क्वायर होगा ना, एक्सेलरेशन ड्यू टू ग्रेविटी एट द सरफेस. सो gm by r स्क्वायर, gm by r इंटू r, यहाँ पे r लिखना होगा, सॉरी. सो दैट इज v स्क्वायर बाई r. अब हमारा एस्केप वेलोसिटी क्या होता है? रूट अंडर 2gr. सो यहाँ पे आप क्या लिखोगे? रूट अंडर 2 इंटू एक्सेलरेशन ड्यू टू ग्रेविटी. g का वैल्यू कितना आया है हमारा? v स्क्वायर बाय r इंटू r करोगे. ठीक है. तो ये कितना हो जाएगा? v रूट अंडर 2. समझ रहे हो? जस्ट यू नीडेड टू कैलकुलेट द escape velocity in term of v. Done. So we calculated the value of v. Calculated value of v is this much. Done. And now you just write the escape velocity, that is 2gr. g का वैल्यू आप पुट कर दो in term of velocity v. So g का वैल्यू क्या होगा? gm by r स्क्वायर. तो यहाँ पे gm by r into r लिखोगे, है ना. gm by r किसके बराबर होगा? v स्क्वायर by r. डन डन डन. So you just needed to just manipulate things. Question को देखो, advanced में जिस तरह से question आता है ना, you just need to get familiar with it. If you're solving more and more question, you will get idea of कि क्या करना है, ठीक है? क्योंकि कई दफा क्या होता है ना, we just look at the question and we feel like कि no, क्या करना है समझ में नहीं आ रहा. करके देखो, just take steps. चलो, do it now. Again, don't give up, do it. I'm giving you 4 minutes for this question. Read the question carefully. Again, I will say, question is not difficult. Concept used is very easy. Only thing is you need to deal with calculation properly. So chalo karo. यार जी मेन तो बहुत इजी हो गया है ना. I can't say easier than that. लेकिन G mains is now like putting the formula, getting the answer. Not even calculation is there much done. So G mains is like it has stooped down to another lower level. चलो अगर easy लग रहा है तो it's very good. Do it now. I hope आप लोग कर रहे हो. At least you are halfway to the answer. When I will explain, you will feel like this question was too easy. चलो डन है. You need more time. If someone is like just closer to the solution, I can give you more time if required. चलो ठीक है. So what the question is here, two spherical stars are there, A and B. तो चलो यहाँ पे मैं पहले स्टार बनाती हूँ. This is A and this is B. Now what the informations are given for them? A and B have same radius, दोनों का ही radius same है. Their masses are related as mass of B is double the mass of A. So suppose mass of A is M, so mass of B will be 2M. Done. Due to an interaction process, and their densities are also given. Yes. Have densities rho A and rho B. Its density is how much? Rho A, and its density is how much? Rho B. Now what is happening? They are interacting with each other, and as a result of that interaction, what has happened? Star A loses some of its mass. A is losing some of its mass, so that its radius is half. Now because of the interaction process, what happened? A छोटा हो गया, इसका radius r/2 हो गया. It has lost some of its mass, but it has retained its spherical shape, and its density is also remaining same. So if density is remaining same, shape is also spherical, radius is r/2, then how much mass A has lost, and A dash will have how much mass now? Yes, correct. That's true. Chalo. So A has lost how much mass that we can calculate. So let's calculate mass of A beforehand. That I have taken as M. So sorry. M can be written as what? 4/3 pi r cube into density of A. Then initially A ka radius is R, density is rho A, and this M must be equal to volume into density, right? Now for another the mass that it has lost, and it lost some mass, and it has become this A dash. Now mass of this A dash can be written as what? M dash अगर मैं लिखूं तो क्या लिखूंगी? Its volume how much it is? 4/3 pi r cube. r/8 हो जाएगा into density. Done. And if you look at it carefully, 4/3 pi r cube rho A. 4/3 pi r cube rho A is equal to small mass M. So this is m/8. It means new mass of the A star is m/8. So how much mass it has lost? It has become from M. It has become m/8. So delta M value, if I'm going to write, it will be M minus m/8. That is 7m/8. So this much mass it has lost. Now let's move ahead to the question. Entire mass lost by A is deposited as a thick spherical cell on B with the density of cell being rho A. Now let's consider on B. B is not losing any mass first of all, and whatever mass A has lost, that is getting deposited on B in the shape of a spherical cell of certain radius it must be, but that cell has a density again equal to rho A. तो चलो मैं यहाँ पे ड्रॉ करती हूँ उसको. If we are going to draw that, what we will be getting? This will be the spherical cell. Here there will be masses, and if you consider this cell has radius r dash, then it will have hollow region. This r dash will have hollow region in this, and mass deposited here. B already has mass how much? 2m. ठीक है. Extra mass how much it is getting? 7m/8. So total mass of B को अगर अब आप लिखो mb, तो आप क्या लिखोगे? 2m plus 7m/8. So how much it is becoming? It is becoming 23m/8. That is mass of B. Now what the question is? Question अब समझते हैं. If B and BB are the escape velocities from A and B after the interaction. So after the interaction, escape velocities from the surface of A and B. Done. तो हम लोग escape velocity कैसे निकालते हैं? देखो question is actually like कि अब हम लोग इसका आंसर लिखते हैं. तो हम कैसे लिखेंगे? escape velocity on the surface of A, for the surface A, for the star A I am saying after interaction, यानी कि from A dash I am talking. तो escape velocity का फॉर्मूला क्या होता है? 2gr. अगेन अब आप लिखोगे 2g का वैल्यू क्या होता है? gm by r, where m is the mass of that star or that planet. तो यहाँ पे m का वैल्यू क्या है? m by 8. सो आप यहाँ पे क्या लिखोगे? gm by 8. इसका रेडियस कितना है? मास लिख लिया हमने, सॉरी पहले तो मुझे g का वैल्यू लिखना होगा ना, तो r का स्क्वायर करूंगी, तो r कितना है? r/2 का स्क्वायर करूंगी, इनटू क्या करूंगी? अगेन रेडियस r/2, क्योंकि 2gr, स्मॉल g आई हैव रिटन, सिमिलर थिंग, चलो इधर दिख नहीं रहा तो मैं इधर करती हूँ, ठीक है। सो एस्केप वेलोसिटी फॉर फर्स्ट क्या लिखेंगे हम लोग? 2gr हमें लिखना है, तो मैं क्या लिखने वाली हूँ? 2 into g into mass of a star A after interaction, that is m by 8. इसका रेडियस आफ्टर इंटरेक्शन हाउ मच इट इज? इट इज r/2. तो r/2 का स्क्वायर करोगे, है ना, gm by r स्क्वायर इनटू रेडियस, दैट इज r/2. सो दिस वैल्यू वी आर गोइंग टू गेट, कितना होगा? ये 4 ऊपर जाएगा, 2 यहाँ पे सारे ही ये 2 इसको 4 टाइम्स से कटेगा, r/2 का स्क्वायर, r²/4, तो ये 4 कट जाएगा, gm by r स्क्वायर इंटू r/2, एक r कट होगा, तो यहाँ पे क्या लिखने वाले हो? gm by 2r. दैट इज एस्केप वेलोसिटी फॉर द फर्स्ट, स्मॉल m, ठीक है। अगेन फॉर सेकेंड इफ यू आर गोइंग टू राइट, तो सेकेंड का तुम डायग्राम ध्यान से देखो, इसका रेडियस, सरफेस का रेडियस कितना होगा? r' होगा, ठीक है, जो मुझे नहीं पता है। तो मैं अब क्या करूंगी? 2 into g मास, मास कितना है इसका? अगर मास आप क्लोजली देखो तो 23 m/8 है, तो मैं यहाँ पे मास पहले लिखती हूँ, 23 m/8, रेडियस नहीं पता, r' का स्क्वायर इंटू r', तो व्हाट विल बी द आंसर? 2g इंटू 23 m/8 r'। यहाँ पे टास्क हमारे पास क्या है? टू कैलकुलेट r'। हाउ यू आर गोइंग टू कैलकुलेट द r'? दैट्स द क्वेश्चन नाउ, क्योंकि अगर r' पता है, we can easily take the ratio, right? So let's now go on to calculation of r'. How we can do that? Then, so how we can calculate r'? We know mass of this small mass of this hollow sphere, right? जो concentric hollow sphere है ना, उसका मास हमें पता है. How much mass was getting deposited here? 7m/8. This much mass has got deposited, right? And if we are going to calculate its mass from the density, we already know its mass. But if you are going to calculate that mass from its density, question में दिया गया है कि when it is getting deposited on cell B, its density is remaining as rho A. Done. So if we are going to calculate its mass from volume into density, so what will be the volume of this? इसका वॉल्यूम कितना होगा? इफ यू आर गोइंग टू कैलकुलेट इट्स वॉल्यूम, तो 4/3 पाई r' का क्यूब माइनस इसका जो रेडियस है, इस वॉल्यूम को माइनस करेंगे बड़े वाले वॉल्यूम से, देन वी विल गेट दिस स्मॉल वाला वॉल्यूम, ठीक है। सो दैट आई एम गोइंग टू डू नाउ. सो व्हाट विल बी मास? मास इज ऑलरेडी वी नो 7m/8, ठीक है, एंड दैट विल बी इक्वल टू हाउ मच? 4/3 पाई r क्यूब. हाउ मच? r' का क्यूब माइनस r क्यूब into rho A. Again, you all remember that कि m का वैल्यू किसके बराबर था? m का वैल्यू था 4/3 pi r cube into rho A, है ना? So that is equal to 4/3 pi r' का क्यूब माइनस r क्यूब into rho A. अब आप इसको कट कर दो, 4/3 pi कट हो गया, रो ए कट हो गया, हमारे पास क्या बचा? 7r³ 8 को चलो मैं इधर लेकर जाती हूँ. सो 8r' का क्यूब माइनस 8r³. नाउ हाउ मच वी विल बी गेटिंग? दिस विल बिकम 15r³ इक्वल टू 8r' का क्यूब. नाउ व्हाट विल बी द वैल्यू ऑफ r'? r' विल बी 15 का पावर 1/3 डिवाइडेड बाय 2. So this is my r'. Now put the value of r' here. Take the ratios. ठीक है. So that is what we needed to do in this question. Until this, it was just a steps getting followed, है ना, बस हमें follow करते जाना था, लिखना था. Only thing was the r dash we needed to calculate. Again, its calculation is not difficult if you look at it carefully, है ना. So any doubt? Understood? देखो एडवांस के क्वेश्चन में तुम्हें कैलकुलेशन तो ज्यादा करना पड़ेगा. You will have to keep patience. If you know the logic, if you know the concept, you must solve the question. And for that, you must keep patience. Layer by layer, you must go ahead. Because not all questions you have to do na. In out of 18 questions, if you are able to solve some 9 questions, that is huge also again na. So 9 questions ko properly time de do. Again, I have told some 25% will be easy, very easy. 45% moderate. So you are already covering 70%. So out of these 70%, again, if 20% I neglect, 50% you can do very easily, you know. तो कैलकुलेशन के साथ थोड़ा कॉन्फिडेंस रखना पड़ेगा. क्लियर है? आफ्टर दिस यू विल बी एबल टू डू ना. कोई कुछ बोलो, सारे शांत बैठे हैं, क्या हुआ? यस, आई एम वेटिंग फॉर यू पीपल टू स्पीक समथिंग. कुछ लिखो, कुछ बोलो. यस, वंस. चलो, कुछ नहीं कहना तो अब एक काम करो, ये क्वेश्चन को करो. अगेन यहाँ पे कैलकुलेशन भी ज्यादा नहीं होगा. अब आप लोग करो, ठीक है. आई एम गिविंग यू another 3 minutes, only 3 minutes. It will require less than 3 minutes actually if you solve it. Do it now. Before you solve this question, let me discuss one thing here. जैसे you must have studied, I guess. जैसे suppose कर लो, there are 2 stars, ठीक है. M1 है and another star is M2. And if in the question it is given that they are orbiting, जैसे यहाँ पे देखो क्वेश्चन क्या दिया हुआ है, distance between 2 stars of masses, this is 9r. R is the mean distance between center of Earth and Sun. That is again another relation that is given. And mh is the mass of Sun. Then the 2 stars orbit around their common center of mass. Again, what happens? Suppose kar lo, there are 2 stars given, and if they are orbiting because of mutual gravitational force, what will happen? Where will be the center of that orbit? So center always used to be that center of mass. So यहाँ पे given है, the 2 stars orbit around their common center of mass. So for first mass N1, radius will be R1, and for second mass radius will be R2. Don't think like कि ये दोनों ही कुछ ऐसे ऑर्बिट में जा रहे, ऐसे ऐसे घूम रहे, नहीं. M1 का रेडियस R1 होगा, M2 का रेडियस R2 होगा. एंड यहाँ पे टाइम पीरियड दिया हुआ, बट यहाँ पे क्वेश्चन ज्यादा कॉम्प्लिकेट करने की जरूरत नहीं है. 2 stars orbit around their common center of mass in circular orbits with period NT, where T is the period of Earth revolution around Sun. तो N का वैल्यू बताना, ठीक. So you can calculate here what rate R1 किसी भी एक के लिए like radius निकाल लो. You can calculate easily center of mass ना. So you can calculate radius. If you can calculate radial, you can calculate omega of any one rotation. M2 के लिए निकाल लो, M1 के लिए निकाल लो, दोनों ही same जाएगा. So what you will be getting, सेम और डिफरेंट भी हो सकता है. लाइक आई जस्ट नीड टू चेक विद द कैलकुलेशन. समझ रहे हो ना? फर्स्ट ट्राई, आई एम गिविंग यू 2 मिनट, ठीक है. ट्राई करो, उसके बाद देखते हैं. वंस अर्थ का जैसे यहाँ पे जो तुम्हारा ये है ना स्टार दिया है ना, स्टार का टाइम पीरियड इज गिवन एज, टाइम पीरियड कितना दिया हुआ है स्टार का, n इंटू टी। टी जहाँ पे क्या है, टी इज टाइम पीरियड, इज द पीरियड ऑफ अर्थ रेवोल्यूशन अराउंड सन। सो अगर तुम्हें कंपेयर करना है, एन का वैल्यू निकालना है ना, सो यू मस्ट हैव गॉट सम वैल्यू ऑफ टाइम पीरियड फॉर द स्टार, ठीक है, वो तो मिल गया। अब उसको कंपेयर करना है ना इस इक्वेशन से, तो यहाँ पे तुम्हें टी का वैल्यू तो रखना पड़ेगा ना, सो यू जस्ट नीड टू राइट दैट वैल्यू, तो हाँ निकालना पड़ेगा, just in the form of formula only, nothing more than that. ओवर, तुम लोगों ने ग्रेविटेशन पहले सॉल्व नहीं किया क्या, कुछ भी नहीं किया ग्रेविटेशन में? देखो सबसे पहला जो यहाँ पे कॉन्सेप्ट लर्न करने का वो है कि इफ टू मासेस आर गिवन, हियर टू मासेस आर ह्यूज मासेस, स्टार्स दे आर, so if two masses are given and if they are rotating around, if they are like going round and round under influence of gravitational force, where will be the center? I told you that will be your center of mass. So first mass will go around in a circle of radius this, and second mass will go around circle of center R2, सर्कल यहाँ से पास करेगा, ठीक है, डन। सो ये तो चलो एक अलग सा कॉन्सेप्ट हुआ, yes one, correct. So what we have to do here, it is said that ki both these stars are orbiting in circular orbit with period how much, np, ठीक है। So for just pick any one star and calculate time period for that, done. So suppose I am picking up 3m, चलो मैं यहाँ पे एक बनाती हूँ, ये 3m है और ये तुम्हारा क्या है 6m है, डिस्टेंस बिटवीन देम इज हाउ मच, यस फर्स्ट करेक्ट, so distance between them is how much, it is equal to 9r. First try to locate the center of mass, तो center of mass calculation how we used to do, suppose कर लो मैंने इसको origin मान लिया, इसको x axis मान लिया, इसको y axis मान लिया, तो xcm center of mass will lie on the x axis, xcm value will be how much, 3m into 0 plus 6m into 9r divided by sum of both masses, and that is equal to how much, and that is equal to 6m plus 3m, that is your 9m, right? If you're going to calculate it, we will get 6r. So first mass, that is 3m, is at a distance of how much, is at a distance of 6r from the center of mass of these two stars. It means this 3m mass will go around in a circle of orbit how much, 6r. Now if it is going around in a circle, अगर ये ऐसे सर्कल में जा रहा है 6r के सर्कल में, there must be centripetal force acting towards the center, and that centripetal force will get provided by gravitational force acting between 3m and 6m. So what will be the value of gravitational force here? So if you see here, gravitational force will be equal to gmm, that is 3m into 6m by डिस्टेंस का स्क्वायर, कितना डिस्टेंस था इनके बीच का, 9r का स्क्वायर will be equal to, this centripetal force will be equal to m omega square in which radius it is going, 6r. अगेन मास का वैल्यू कितना होगा, 3m मास इज गोइंग अराउंड दिस सर्कल ना, तो यहाँ पे 3 लिख लो, ठीक है। नाउ दिस m will get cancelled, done. What value of omega we are going to get, just do the calculation यार, क्या आएगा यहाँ पे बताओ, people please be quick with the calculation, थोड़ा हेल्प करो। So these 3 got cancelled, ठीक है, यहाँ पे 6 है, ये 6 भी क्या हो जाएगा, कैंसिल हो जाएगा। ओमेगा स्क्वायर का वैल्यू क्या दिख रहा है मुझे, ये r जो है वो नीचे आएगा, so ओमेगा स्क्वायर इज समथिंग gm by 9r cube, ठीक है. So omega value we can calculate how much, root under gm by 9r3. Done. What will be the time period here? Time period क्या होता है हमारा? That used to be 2 pi by omega. So it will be 2 pi 9r3 by gm. ठीक है. So this is the time period we have got for the star. Now this is given as equal to n into t, where t is what? Time period of earth around sun. अब आप देख लो टाइम पीरियड ऑफ अर्थ अराउंड सन कितना होगा. अर्थ का मास क्या दिया हुआ है, सन का मास क्या दिया हुआ है, ms is the mass of sun here. ms mass of earth को सपोज कर लो मैंने स्मॉल m ले लिया. Again if it is going in a circle of radius r that is given in the question, r is the mean distance between center of earth and sun. Done. So if that is the case, here also we can write centripetal force, that is m omega square r. यहाँ पे ओमेगा का वैल्यू कुछ और होगा, and that will be equal to gravitational force acting between these two. तो ms into m by r square. m तो कैंसिल हो जाएगा. So ओमेगा का वैल्यू मुझे क्या मिल रहा है, g ms by r cube root under. What will be the time period here? Time period here will be 2 pi by omega, that is r cube g ms. ठीक है. अब आप इस टाइम पीरियड को कंपेयर कर लो. टी डैश का वैल्यू हमें क्वेश्चन में क्या दिया हुआ है, n इंटू टी. तो चलो इसको लिखते हैं. इसको अगर मैं फिर से रीराइट करूं तो आई कैन राइट इट लाइक 9 इंटू 2 पाई आर क्यूब बाई जी एम एस. तो दिस इज इक्वल टू टी ना, है ना. तो 9 इंटू टी आंसर आ रहा है. सो व्हाट विल बी द वैल्यू ऑफ n, दैट विल बी इक्वल टू 9. ठीक है, चलो डन है ये क्वेश्चन. एक काम करते हैं, दिस क्वेश्चन फ्रॉम ग्रेविटेशन वी विल बी पिकिंग अप टुमारो इन द क्लास. वेरी फर्स्ट क्वेश्चन वी विल बी डीलिंग विद दिस. आज थोड़ा वेव में घूमते हैं, एसएचएम में घूमते हैं. ठीक है, दैट इज योर सिंपल हार्मोनिक मोशन. अगेन you must have realized through those 5 questions key what is important, just the basic knowledge, just the basic. And extra thing is what, calculation. Here also same things you will be encountering, because nothing much we have to get here in SHM, simple harmonic motion. Just basic concept we need to keep in our head. So what are those basic concepts? What is simple harmonic motion? First of all, this is periodic. And how to identify that any motion is going to be simple harmonic motion. तो आपने जरूर पढ़ा होगा कि if acceleration of any system or two mass system or single three mass system is directly proportional to displacement, magnitude wise if I say this, and if I use vectorial sign, then this must be proportional to this like this. Done. यानी कि magnitude should be directly proportional to x and direction should be opposite. Done. And it means displacement and acceleration का direction क्या होता है, हमेशा opposite होता है. So this is the basic rule for any body to follow the SHM. Now how we write the equation of SHM? Done. So equation of SHM we write as cos or sine function. Simple. Done. So if a body is suppose performing SHM along x-axis line, ठीक है, तो बेसिक तो आपको जरूर पता होगा ना कि एक मीन पोजीशन होता है, एक होता है एक्सट्रीम पोजीशन, another one also extreme position. So what happens? My body can start from anywhere. Then it may be कि my body was initially at t equal to 0, it was at mean position, and then it started oscillating. It was displaced towards one of the end, and after that it started performing SH. So initial position can be anything. It can be at mean, it can be at extreme, it can be anywhere between mean and extreme. So how to write the equation? So simple equation लिखने का तरीका ये है कि its displacement will vary as a, that is amplitude sine omega t plus phi. ठीक है. Now distance measurement happens from where? From mean position. ठीक है. So this will act as an origin. Basic. This will act as an origin, right? So this became origin. What is the significance of this thing? This is amplitude. This is displacement of that particle from mean position at any time t. What is this? This is phase. And phase means it will tell you at what time it is where. Phase is very important. Now, if you go inside phase, you are getting two things. One is omega t and another is phi. This omega t wala term will depend on time. As time is changing, omega t will change, right? But this phi is a constant. So this is phase constant. This is called as what? Phase constant. So whatever term inside sign is independent of time is called phase constant. And it is this phase constant that tells us where the particle is at t equal to 0. Done. So suppose we have to check that my particle is where at t equal to 0. So what you will do? You will put t equal to 0. So आप क्या करने वाले हो? You will do something like you will write x equal to a sin. अब t का value 0 टाइम पे मुझे x निकालना है, so 0 plus phi you will be doing. So x का value क्या आ जाएगा? A sin phi. And this will tell you the value of phi. Sin phi will be equal to what? X by a. So blindly anywhere you can write equation of SHM as this. You can calculate value of phi according to whatever things is given in your question, and you can complete this equation, right? So that's your SHM. From here you can calculate velocity, है ना? ये सब डिस्कस करने की जरूरत नहीं, dx by dt करके निकाल सकते हो. Acceleration you can calculate by d2x by dt square, और simply v निकाल चुके हो तो dv by dt कर लो, ठीक है? So everything you can calculate from here. Done. Just logic I was dealing with. Now one more thing, like spring के केस में आपने पढ़ा होगा कि when a spring is in series and when a spring is in parallel, how to identify it, first thing. And second thing, what are the basic notes that defines a particular spring is in series and particular spring is in parallel. जैसे कभी कभी क्या होता है, जैसे हमने ऐसा देखा spring को, तो हम we have so much dealt with register in parallel ना, कि by looking at the spring we say कि this spring is in what, this spring is in parallel. But what the basic is, why it became in parallel, that's the question. Because in electrical circuit you must have studied two resistors are in parallel because potential difference between these two happens to be same, right? Here what is same, that point we have to search for. So anyone, chalo theek hai, koi nahi. So what will be same here? For that you just see, you just extend it by distance some x. Suppose I am just stretching this mass m by distance x. What will happen here? What will happen here? This spring, suppose कर लो इसका spring constant k1 है, इसका k2 है. So k1 spring will come down by distance x. K2 spring will come down by distance x. So both of these spring are suffering displacement x, means equal displacement. So if displacement is equal, we say a spring is in what? A spring in series. Sorry, a spring in parallel. ठीक है? Done. यानी कि यहाँ पे दोनों का ही displacement क्या होने वाला है? Same, x. So that is same. And you all know that if we have a spring in parallel, how we add them? Anyone? How we add them? जल्दी से बताओ. If a springs are in parallel, how we will add them? Yes, like series. How it is coming like series? From this logic only. Displacement क्या हुआ है दोनों में equal. You can check that. ठीक है. Similarly, if there is, yes, check. Like register in series we are going to add. So यहाँ पे K equivalent क्या हो जाएगा? K1 plus K2. Now what is the way to check if a spring in? जैसे देख लो, suppose कर लो मैंने एक केस दे दिया जो कि बहुत ही फेमस है. अगर मैंने मास को यहाँ रखा और यहाँ रखा, अब मैं पूछ रही हूँ कि ये दोनों स्प्रिंग किसमें है, सीरीज में है या पैरेलल में? हाउ यू विल आइडेंटिफाई दैट? फॉर आइडेंटिफाइंग सिंपली डिस्प्लेस द मास. तो चलो मैंने इस मास को डिस्प्लेस कर दिया इधर x डिस्टेंस से. So K1 spring will get compressed by x and K2 spring will get extended by x. But displacement is same now, value wise. So these two springs are in what? Parallel, because their displacements are same. So यहाँ पे K equivalent क्या हो जाएगा? Yes, यहाँ पे K equivalent क्या हो जाएगा? K1 plus K. So you all people know. Now series का क्या idea है? Series में like if springs are like this, And if it is connected to this, what happens? Suppose this is K1, this is K2, this is K3. Suppose K3 is greater than K2 is greater than K1. What is happening? Now I am displacing this mass m by distance x. What will happen? सबसे पहले these springs are massless, and you must have studied in your mechanics that if a string is massless, tension throughout will be same. So tension throughout is same everywhere. Force acting on this spring are same, but a spring which has more spring constant is a hard one, so it will displace by little distance. Then K2 will displace by a little more, and K1 will displace by a little more and more. Done. So if it is suffering displacement x3, if it is x2, if it is x1, then x3 plus x2 plus x1 must be equal to x. Logic. And second thing, K3 is greater than K2 is greater than K1. It means x3 is less than x2 is less than x. Done. उसके बाद tension is same. It means K3 x3 is equal to K2 x2 is equal to K1 x. So these are the things in series that you need to remember. अब इसको series में add करना है तो parallel की तरह add होता है. The way you add resistors in parallel, same way you will add springs connected in series. ठीक है? तो चलो अब इस क्वेश्चन को करके मुझे बताओ. Question is again damn easy, but you need to be careful with a small details. ठीक है? So 4 minutes I am giving you to solve it. डायग्राम सही से बनाना, डिटेल सही से लिखना कॉपी में. ठीक है? लिखना मतलब मेक द डायग्राम, राइट की कहाँ पे x 0 होगा, कैसे कैसे डिस्प्लेस हो रहा है. डन. x आइडेंटिफाइंग x इक्वल टू 0 इज इंपॉर्टेंट ना, तो सही से ज्योमेट्री को डील करना. डू दिस क्वेश्चन नाउ. चलो ठीक है. You must have tried now. It's like I give you some more than 5 minutes. So let's see now. A spring block system is resting on a frictionless flow as shown. I told you now. What are the general way to identify SHM? A is directly proportional to minus x. Done. One more thing you can keep here is A हमेशा ही किसके बराबर होता है माइनस ओमेगा स्क्वायर एक्स है ना ऐसा कुछ आता है SHM में एंड टाइम पीरियड का वैल्यू क्या होता है हमारा 2 पाई बाई ओमेगा सो फ्रॉम हियर वी कैन कैलकुलेट ओमेगा फॉर अ स्प्रिंग हाउ वी कैलकुलेट ओमेगा स्प्रिंग के लिए फोर्स क्या होता है माइनस के एक्स होता है ना m इंटू ए आप क्या लिखोगे माइनस के एक्स ए क्या होगा माइनस के बाई एम एक्स तो ओमेगा स्क्वायर किसके बराबर है के बाई एम यू ऑल मस्ट बी अवेयर ऑफ इट राइट टी इक्वल टू क्या लिखोगे 2 पाई बाई ओमेगा सो आंसर क्या होगा 2 पाई एम बाई के दिस इज now in this question what the question is first a spring block system is resting frictionless flow है the spring constant is given k ka value is how much 2 and the mass of block is how much 2 kg this is 1 kg right ignore the mass of a spring is massless initially spring is in unstretched condition initial position of a spring is this it is not extended at all now what will happen 8 seconds so another block of mass 1 kg moving with a speed of 2 meter per second this is moving with how much speed 2 meter per second collides elastically with the first block so यहाँ पे पहुंचा होगा ठीक है ये ब्लॉक 1 kg 2 kg से क्या किया इलास्टिकली कोलाइड किया देन collision is such that 2 kg block does not hit the wall 2 kg block is not hitting the wall so what will happen during collision during collision 1 kg block will hit 2 kg block in this direction so 2 kg block will start moving towards the spring so it will start compressing a spring what will happen to 1 kg block after the collision either it will move in this direction with less speed or its speed will get reversed so that we need to check now at the collision what is happening so if we are considering 1 kg 2 kg block as a system then what happened like 1 kg and 2 kg block as a system agar hum log consider kare then during collision what will happen momentum will remain conserved done kyunki before collision 2 kg is at rest 1 kg is at rest during collision what is happening force is only acting between 1 kg and 2 kg so this force is becoming internal right so if we are considering 1 kg and 2 kg as a system momentum will remain conserved so initial momentum what you will be writing initially 2 kg momentum is 0 1 kg momentum is equal to 1 into 2 finally suppose कर लो मैंने assume कर लिया कि दोनों ही इस डायरेक्शन में जा रहे हैं आफ्टर कोलिजन so final momentum I am writing v1 plus 2v2 1v1 into plus 2v so initial momentum will be equal to final momentum what you will be writing 2v2 plus v1 equal to 2 now two variables one equation we need one more equation right so एक और equation अगर एनर्जी का लिखे तो complications काफी बढ़ेगा done but one more equation we can write from the fact that collision is elastic and in elastic collision coefficient of restitution used to be 1 what is coefficient of restitution velocity of separation by velocity of approach so separation means velocity of separation means relative velocity after collision velocity of approach means relative velocity before collision so E का value 1 है that will be equal to v2 minus v1 by 2 minus 1 done so v2 minus v1 equal to how much 2 2 minus 1 नहीं initially तो 0 था ना first का 2 kg का speed so 2 minus 0 now this is this and this is 2v2 plus v1 equal to 2 if we are going to add these two what value we will be getting 3v2 equal to 4 so v2 equal to 4 by 3 v1 कितना आएगा अगर आप यहाँ पे v2 4 by 3 minus 2 करोगे तो v1 का वैल्यू कितना आ रहा है minus 2 by 3 यानी कि the direction that I have taken is wrong if this direction will be here done so 1 kg mass will start moving in this direction with how much velocity 2 by 3 meter per second 2 kg mass will start moving in this direction with how much velocity 4 by 3 meter per second Now what the question is, distance in meter we have to calculate between two blocks when the spring returns to its unstretched position for the first time after collision. So what is going to happen after collision? If we look carefully, so after collision 2 kg block will start moving towards the wall. So if it is moving towards the wall, a spring will get compressed. तो चलो मैं इस पोजीशन को x इक्वल टू 0 मानती हूँ. क्यों? क्योंकि इट इज आस्क्ड दैट कि पोजीशन डिफरेंस बिटवीन देयर पोजीशन आफ्टर द कोलिजन. So just at the moment of collision, we can say कि their separation is what? 0. So x equal to 0 here I am taking. Now what will happen? It will compress it to the maximum level. Done. And during that time, this 1 kg body is going there. So we don't need to worry about that. This 1 kg is moving here in this direction. Done. So let's focus on 2 kg. So 2 kg के साथ क्या होगा? First, it will compress it to the maximum level. Suppose maximum compression is x. After this maximum compression, again it will come back to x equal to 0. Done. So here it will come. Again x distance it will cover and come back here. So it will take some time t1 in compressing the spring. Again another time t2 in coming back to its normal position at x equal to 0. And during this time t1 plus t2, 1 kg block must have moved by distance how much? t1 plus t2 into v1, that is 2 by 3. Then so suppose कर लो कि 1 kg block कहीं इधर पहुंच गया, so this distance we have to calculate. So basically we have to calculate t1 and t2 now. So in what time it will compress the spring? Time period क्या होता है? That is 2 pi root under n by k. Done. And we already know that कि if during compression means अगर आप ऐसे देखो symmetry अगर हम लोग check करें तो we have learned that कि in going from mean to extreme position it will take t by 4 time, where t is the time period. Again coming from mean to extreme to mean position it will take another t by 4 time and so on. बट अगेन मैंने क्वेश्चन डिस्कशन में भी ये इंपॉर्टेंट चीज बताया है कि कभी भी सिमेट्री का यूज और दूसरे पॉइंट्स तक पहुंचने में जो टाइम लगेगा उसके लिए मत करना. डोंट डू लाइक कि a/2 डिस्टेंस तक जाने के लिए ये सिमेट्री का यूज नहीं करोगे. ये मत करना कि a तक जाने में टाइम लगा t/4 तो a/2 तक क्या लगेगा. डोंट डू दैट. फॉर दैट वी विल बी using equation x equal to a sin omega t plus 5 whatever it is. ठीक है. But symmetry we can use for extreme and mean position overall. So यहाँ पे टाइम क्या लगेगा? Total t/4 compressing and another t/4 while coming back to the mean position. So total time क्या हो गया? t/2. तो t/2 का वैल्यू क्या हो जाएगा? pi root under n by k. What is the n का वैल्यू? is 2 kg. k का वैल्यू is 2 kg. So this is pi. Time is pi. Right. Now if time is pi, t1 plus t2 is pi, so this will become pi into 2 by 3. So pi क्या होता है? 3.14. Done. So time almost 2 के बराबर होगा. Clear है? Sorry, distance almost क्या होगा? 2 के बराबर. Done. So the answer will be 2. Done. We are done for today's class now. In the next class again I will be picking up one question from gravitation, some more questions from SHM and some questions from wave I will be including. ठीक है. SHM में some more one or more 2 concepts more I will be discussing, and after that I will suggest you कि today in your home if you are getting time there in your schedule, what you do, you practice some questions from SHM and gravitation. ठीक है. तो आप करो according to your convenience. Okay. Let's meet tomorrow then. Till then, take care. Stay positive. Keep on doing more and more questions. Don't bother about what will happen, what not. Not in your hand. Only thing in your hand is to do work. So काम करो और मजे भी करो. Rest भी लो. Tension मत लो बस. ठीक है. Bye bye. Tata. Take care.